To start with, we're going to talk about the unit circle because it's so very important. Unit circle is merely a circle with a center at the origin and a radius of 1. To start with, let's, I hope you can see the pen. Okay, I'm going to do a quick little test. So that would be 0 degrees, which I think you can see fine. So there's 0 degrees. If we count the middle marks, we'll count by 45, because all the way around the circle is 360, so this would be 360 right here. So if we count by multiples of 45, we would say the middle is 45, and then the top would be 90. That makes sense, 45 would be right in the middle. And if you added 45 to that, you would get 135. And then 180, and if you add 45 to that, you get 225, and then you get 270 for down here, and then you would get 315 degrees right here. If you count by multiples of 30, then you get 30, and then 60, we already have 90, then 120, and then 150, then 180. If you add 30 to that, you get 210, and then you get 240, then 270, and if you add 30 to that, you get 300, and 30 to that, you get 330 degrees. So there are all of our degree measures. If you do the 30s first, because if you have difficulty with the 45s, if you do the 30s first, you just add 15. So 120 and 15, 135. 30 and 15, 45, 210 and 15 give you 225, 300 plus 15 gives you 315. Okay, now let's do the coordinates. So right here at 0, we have, if this is the origin and it's got a radius of 1, this has the coordinates of 1, 0. At the top, this would be 0, 1, and over here would be negative 1, 0. And at the bottom would be 0, negative 1. Alright, there are only 5 numbers as far as the coordinates go on the unit circle. They are, let's think about this for a minute. There's 0 and there's 1, and then there's square root of 3 over 2, and then there's 1/2, and then there's square root of 2 over 2. Okay? Only these 5 numbers, so it's really not that hard. We already showed where 0 and 1 are, and of course sometimes they're negative or positive, but that's 0 and 1. So the only other three numbers left are these: square root of 3 over 2, 1/2, and square root of 2 over 2. You could call 1/2 square root of 1 over 2, and so going from smallest to largest, it would be square root of 1 over 2, square root of 2 over 2, then square root of 3 over 2. Okay, and we know that square root of 1 is just 1, so this is really just 1/2. But this is their order, in order from smallest to largest. So 1/2 is the smallest, then square root of 2 over 2, then square root of 3 over 2. Okay, so when you do 45s, you could remember, I always remember that the middle one, the one that's in the middle, you know, going from smallest to largest, that goes in the middle of every quadrant. And right in the middle are all the multiples of 45. So at 45 degrees, it's just square root of 2 over 2, square root of 2 over 2. We get these numbers from our knowledge of 45, 45, 90 triangles, because if you drew a line from here to 45 and then drew a line down, this would be a right angle. This would be square root of 2 over 2 over, square root of 2 over 2 up, and the radius would be 1. Okay? We know that in the first quadrant, everything's positive. Second quadrant, x's are negative, y's are positive. Third quadrant, x's are negative and y's are negative. And in the fourth quadrant, x's are positive and y's are negative. Okay, so if you go straight across right here to the middle of this quadrant, the coordinate's exactly the same except for the x part's negative. So it's negative square root of 2 over 2, positive square root of 2 over 2. And if you went directly down to the middle of this quadrant, the same thing, but in this quadrant everything's negative. So you'd have negative square root of 2 over 2, negative square root of 2 over 2. And if you went straight across here, it'll be the same point, but only the y value is negative. So square root of 2 over 2, negative square root of 2 over 2. So look, we're almost done. All we have are the multiples of 30 and 60. Okay, so if you want, let's do 30 first. I want you to think about, like, if you made this into a triangle. I'm just going to, I guess I can go ahead and just draw it. I'll dot it in. If you make that a triangle, so now the only things we have left are 1/2 and square root of 3 over 2. Can we see those on the screen? Not really. I'm sorry. I kind of did away with my logic here, but sorry, because I just noticed you couldn't see this on the screen. Alright, so all we have left are 1/2 and square root of 3 over 2. If you look at 30 degrees, you go over more. So of these two, square root of 3 over 2 and 1/2, square root of 3 over 2 is the biggest. And you go over the most and you go up a little. So we're going to go over square root of 3 over 2 and up 1/2. If you went straight over here, directly straight across is 150. Notice both of these live 30 degrees away from the x-axis. It's going to be exactly the same coordinate except for the x value will be negative. So it's negative square root of 3 over 2 and up 1/2. And if you go 30 degrees south of 180, both of them are negative. So negative square root of 3 over 2, negative 1/2. Then if you go straight across over here to 330, same coordinate, but the x is positive and the y is negative. Okay? And then lastly, if you think about 60 degrees and the triangle that you'd make if you did this, we already know the radius is 1. You'd go over a little and up a lot. So this would be over 1/2 and up square root of 3 over 2. And then over here we would have negative 1/2 and up square root of 3 over 2. And then straight down we'd have negative negative, so negative 1/2, negative square root of 3 over 2. And then straight across here we would have positive 1/2, negative square root of 3 over 2. Alright, we have all of our coordinates in. Now we're going to talk about radians. And to include the radians in the discussion, we need to remember that the formula for circumference is, make sure I can still see this, yeah. The formula for circumference is equal to 2 pi r, all right? Since our radius of this circle is 1, that means our circumference is 2 pi times 1, or just 2 pi all the way around. This is where we get our radian measures from. Okay, is from this notion that since circumference is 2 pi of a circle with radius 1, that we can measure the circle that way. So this would be 0 right here. And let's look for a minute. Let's say I dot in all of these multiples of 30 for a minute. Not the middle, not the very middle of the circles, but these other ones here, like this, okay? So notice there's 1, 2, 3, 4, 5, 6. This is 0. All the way around the circle's 2 pi. So we put 0 here. We would put 2 pi here. You start with 0, then you go all the way around, and then it's 2 pi. So that means over here would be pi. And between 0 and pi, there's 1, 2, 3, 4, 5, 6 divisions. So each one of these is going to be 1/6 of a pi. Or we're going to count them by pi over 6, we're going to say. So we would say that this is pi over 6. 60 degrees, it's 2 pi over 6. But 2 pi over 6 reduces just to be pi over 3. So that's what we'll put in our box. So 2 pi over 6. Up here would be 3 pi over 6, but that would reduce to be pi over 2. So we have pi over 6, 2 pi over 6, 3 pi over 6. The next one is going to be 4 pi over 6, but that reduces to be 2 pi over 3. The next one here is going to be, because this was 4 pi over 6, so 150 will be 5 pi over 6. At pi, this would be like 6 pi over 6, but of course that would reduce to be pi. At 210 it would be 7 pi over 6. Down here by 240 this would be 8 pi over 6, but that reduces to be 4 pi over 3. And down here at 0 it would be 9 pi over 6, but that reduces to be 3 pi over 2. Right here would be 10 pi over 6, but that's going to reduce to be 5 pi over 3. And then the last one here will be 11 pi over 6, and that doesn't reduce. So you notice all these ones that are just like 30 degrees away from the x-axis, they all have the 6's still. So it's pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. The ones that are farther up here, these are all the 3's. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. 3 pi over 3 is right there. Alright, so the only thing I'm missing are all the multiples of 45. If you drew a line to each one of the middles of your quadrants, they're not very straight, but you get the idea. And if this is 0 radians and this was pi radians, that divides our little pi up into 1, 2, 3, 4 pieces. So we count by pi over 4. So at 45 degrees it would be pi over 4. Up here at the top would be 2 pi over 4, but of course that reduced to be pi over 2. Then right here at 135 we'd have 3 pi over 4. Right here would be 4 pi over 4, but that reduces just to be pi. And then we would have 5 pi over 4, because this was 4 pi over 4. So right here would be 5 pi over 4. And then right here we would have 6 pi over 4. But of course that reduces to be 3 pi over 2. And then lastly we would have 7 pi over 4. And it would go right there. So there we have all of our degrees, all of our radians. I'm sorry, you couldn't see this very well right there. All neat and tidy. You have to know this and you have to know it forever, so I hope that helped.